Welcome to Math TV with Professor V. In this video, we're going to learn a technique to help you graph piecewise functions like a boss. And this is a method that I came up with years ago. If you really struggle wrapping your head around piecewise functions, this video is for you. So what exactly is a piecewise function? I'm not going to talk forever about it. But basically, a function is piecewise defined if it's defined by two or more functions on its domain. So usually we break up the domain, as you can see here. All right, oh, let me change that laser point. Yeah, red. Okay, the domain is broken up. Here's one part of the domain, x is less than 1. Here's the other part of the domain, x is greater than or equal to 1. And we have two different functions that make up f of x. And usually, piecewise defined functions are written this way with a little squiggly bracket on one side, okay? So I'm going to show you this technique if you're just on the struggle bus like most students, very normal. Graphing's hard as is. Students don't like it, and then graphing piecewise, whew, gives them anxiety. So here I am to the rescue. Okay, so look here, we have x squared plus 1. Defining f of x if x is less than, but not including 1. So on the table, I'm going to put a few values that are smaller than 1. Okay, let's do -1, 0, and I am going to add 1 to the table. And you might say, Professor V, I think you've gone cuckoo. It says x is less than 1. We can't plug in 1. You're right, but I want to get as dangerously close to 1 as possible. So you tell me, where would you cut it off? 0.9? What about 0.99? What about 0.999? You see how we can get carried away. So what you do when you have a piecewise function like this, you will actually plug in that value for x, but then when you graph it, you're going to graph it with an open circle. You're not going to fill in that circle, yeah? Because it's strictly less than 1. So if you just need a little refresher, if you see an inequality that's less than or greater than, you plot it with an open circle. If you see less than or equal to or greater than or equal to, then you're going to plot it with the closed circle. And then everything else in between would be closed, okay? It's just those borderline points. So I'm going to remind myself, these 3 points, these 3 x values, I'm going to plug into x squared plus 1. Because they fall into the domain here for x less than 1. So I'm going to put that off to the side. X squared plus 1. Good? Okay, now let's see here. If x is greater than or equal to 1, I'm going to plug it into this function. Let's just do a couple more values. I'm going to put 1 again, 2, 3. So yes, wherever the domain is split up, namely at 1, you're going to plug it into both functions. So you double up on this value. When I plug it into x squared plus 1, I'm going to plot it with an open circle. But when I plug it into x minus 2 squared, you see how this is equal to 1? Oh, then this is going to be a closed circle. I always put that there to remind myself, okay? And then these 3 points will get plugged into x minus 2 squared. All right? Now, these are both parabolas. Hopefully you recognize that because you have x squared as the parent function. So that should help us know we're going to make a U shape when we plot all these points. And now just fill in. So let's see. -1 squared plus 1, that's going to be 2. 0 squared plus 1 is 1. And then 1 squared plus 1 is 2 also. Just don't forget, when you plot 1, 2, it's going to be an open circle. And then now, these values here, I'm going to plug in for x right here. So 1 minus 2, that's -1 squared is 1. This will give me 0. This is going to give me 1. And remember, 1, 1, closed circle. Okay? All right. So now let's make our graph. And the good thing is we didn't have any really big values. Everything's just between 2, 0, nice. Okay, 1, 2, 3, that should be sufficient. 1, 2, 3. Okay, so I'm going to start here, -1, 2, that's right there. 0, 1, and then 1, 2, I'm going to plot with an open circle, okay? Now, I'm plotting this part of the piecewise function for x is less than 1. So where is x equal to 1? Right here, right? I don't want to draw all the way to, it looks like an asymptote, but anyways. Okay, so the graph is broken up into two pieces. It looks like x squared plus 1 everywhere to the left of 1. And I'm going to put an arrow. I'm going to put an arrow because this graph continues for all x is less than 1, forever this way. This is not a bounded inequality, so you need that arrow. Now let's do the other side. We have a closed circle at 1, 1, 2, 0, 3, 1. And you see how now we have x is greater than or equal to 1, so this is going to go forever this way. Okay? Don't get carried away. And I don't know, I've seen all sorts of, don't keep crossing like this, then it wouldn't be a function. It would fail the vertical line test. So always keep that in mind. These are functions. They have to pass the vertical line test. So don't overlap their domains. Don't get too happy-go-lucky with the graphing. That's it. Really, that's it. Now, once you have enough practice, hopefully you can break away from the table. Because in all honesty, I don't do this anymore when I graph. I go, oh, this is a parabola shifted up 1 unit. I'm only going to graph it smaller than 1, and I'm going to put an open circle, and I just go for it. And then this is a parabola shifted to the right 2. At 1, I'd be at 1, and then I just go for it, okay? And there's nothing wrong with that. So if you're already able to do these problems without making a table, perfect. That's the goal. But I know a lot of students just can't even get something down on their paper, so this method should help you. Let's look at something a little more spicy, yes? Okay. F of x equals, I know, 3 functions. X squared if x is less than -1. X if x is greater than or equal to -1 but less than 1. And 1 over x if x is greater than or equal to 1. Okay, again, same thing. Let's make a little table. X, f of x. And everywhere the domain is split, you're going to list that x value twice or multiple times. What do I mean everywhere the domain's split? At -1, right? We're splitting up the domain and defining f differently, and then also at +1. So x less than -1, we don't need too much. I'll just do like -2 and -1. I know I'm plugging these into x squared. That's a parabola. I'm not nervous about it. See how it's not included, right? X is strictly less than -1, so I'm going to plot that with an open circle, and I'm just going to remind myself, plug these into x squared right now. Okay, then the next piece is from -1 all the way to 1. So -1, that's going to be with the closed circle. Can you tell me why? Do you remember? Yes, because it's greater than or equal to, so that means include that point, closed circle. 0, and then 1, but this time, did you catch it? The 1 is going to be with an open circle, and this gets just plugged into x. And then lastly, I have 1 over x if x is greater than or equal to 1, so let's just do 1. That'll be closed circle, 2. Oh, ugliest 2 I've written in my life. Okay, here we go. 1 over x. Good? Okay. So x squared, let's get the y values now. This will be a +4, a +1. F of x equals x, just spits back out whatever you had for x. And then 1 over x. 1 over 1 is 1, and 1 over 2 is 1/2. All right, so there's going to be basically like 3 pieces that we're putting together. Let's see how it all looks. Again, no really crazy values, so that's good for us. We have to go up to 4. 1, 2, 3, 4. 1, 2, 1, 2. Right? That's pretty much all we did. Okay. So we have -2, 4. -1, 1 with an open circle. And that's for x less than 1. So let me see, for x less than 1. So everywhere on this side, I'm going to be drawing this parabola that opens upward. Okay, let's erase this. So from here, this way. Don't go larger than 1. Okay, next piece. negative 1, negative 1. Let me say that's right there. Negative 1, closed circle. 0, 0, 1, 1, open circle. That's getting plugged into f of x equals x. That's just a line, right? Linear function. Slope is 1, goes through the origin. Very good. Okay, third piece. No arrows on this piece. Let's talk about why. You see how x is bounded between negative 1 and 1? This is not bounded. X is less than negative 1. It goes forever, right, with the arrow. Same thing. We're going to have an arrow on the other side. Whenever you have this little sandwich inequality, it's a bounded inequality. X is trapped between no arrows, no arrows. Also, should you lose your mind and accidentally start drawing an arrow, that's a problem, because then this wouldn't be a function. See how it would fail the vertical line test? Very problematic. Okay, so then you could hopefully catch yourself from doing something wild. Moving on. 1, 1, closed circle. Now you might say, oh, we already have an open circle at 1, 1. Do you see it? How do I draw a closed circle on top of an open circle? You don't. You just fill in the closed circle. You don't make such a big deal about it. Got it? Okay, great. And then 2, 1/2. And I'm good. I know what the rest of it looks like. As long as you know what 1 over x, the parent function, looks like, hopefully you do. If not, then check out my video from my pre-calc lectures. It'll be in the description. If I can remember, I'll link it here. But 1 over x looks like this, yeah? More or less. It's very crude, but it's good enough. There we go. Et voila. How do you like it? I love it, Professor V. Oh, good. So I'll just remind you, this is x squared, this is x, and then this part is 1 over x. Okay? Good. I have 2 more. 2 more. F of x equals 2 to the x if x is less than or equal to 1. 3 minus x if x is between 1 and 4 or equal to 4. And then rad x if x is greater than 4. You can do you want to pause the video? Try it on your own. That could be very revealing or traumatizing. I don't know. Here we go. 2 to the x if x is less than or equal to 1. So let's do like 3 points. Negative. You do however many you need to feel comfortable. I don't need that many, but I'm doing, just a few extra for you people. Here we go. X is less than or equal to 1. That means at that value, we'll plot it with a closed circle. These get plugged into 2 to the x. 3 minus x if x is between 1 and 4. So 1, open circle. Good. 2, 3, 4, closed circle. These get plugged in 2. 3 minus x. Very good. And then rad x if x is greater than 4. So 4, open circle. I really don't want to plug in 5. Rad 5. Ugh. Let's just jump to 9. And these get plugged into rad x. I probably won't even plug it in and graph it, because who wants to draw all the way out to x equals 9? You know what I mean? Okay, here we go. Let's get the y values. So when I plug in negative 1 for x, that's 2 to the negative first power, which is 1/2. 2 to the 0, that's 1. 2 to the first, that's 2. And then 3 minus x, that's just a line, so maybe you don't need so many. 2, 1, 0, negative 1. And then rad x square root of 4 is 2, square root of 9 is 3. Okay. So let's draw what we got here. Only do arrows on the 2 to the x and the rad x part, right? Not the rest. How high up in the y-axis do I have to go? 1, 2, 3. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Look, I'm going to do it all. Negative 1, negative 2. Beautiful. Okay, so we've got negative 1, 1/2, 0, 1, 1, 2. Do you know what 2 to the x looks like? Exponential functions have this sort of a shape, okay? But it's only for x less than or equal to 1. So this is the end of it, and the arrow is going to go this way. And we have horizontal asymptote, the x-axis, y equals 0. Okay, next piece. This is a line. At 1, 2, we have an open circle. Oh, but we just had a closed circle there. So that's cool. Don't do anything extra. Don't draw some weird open circle on top of the closed circle. Just move on. Then we have 2, 1, 3, 0, 4, -1 with an open circle. This is a line. Just connect it. Don't go past. Don't go past. Stop there. This inequality is bounded, so no arrows on that piece. And then x greater than 4, so open circle here at 4, 2. Then 9, 3, and then I know what radix is the upper half of a sideways parabola like this. You know, zoom out, it looks more like that. But we just have a little sliver of it here, okay? How was that? Fabulous? So-so? Just keep practicing, okay? And then you'll get to the point where you'll just say, oh, okay, 2, 1, and I know what an exponential function looks like. This is a line, negative slope. If I plug in 1, yep, I'm going to go to 4, just draw the line. Radix, I know what that looks like. So you won't have to make the table forever, but this is just to get some of you guys going, you know. All right, last one. It's on the practice test if you're in my Calc 1 class. So after you graph it, you're going to need to do stuff and find limits. Here we go. F of x is 3x if, see how this is bounded? So we're not doing arrows on that part or this part. Good? Very good. Then there's this like random little x equals 0, f of x is 3. That means you literally are just going to plot the point 0, 3. If x is 0, y is 3. There's just going to be a little loner point there. And then f of x is 0, so just flat line, x-axis, for x is less than -3 or x greater than 2. So we can make a table if you want. If you don't need it, fabulous. Not a problem. No one's mad at you. Okay, so this is just a linear function. I don't need a ton of points, just a couple, right? We can connect it. I'm going to put -3 with a closed circle. I don't really need any more. Let's just do 0 with the open circle. And then you see how this 0 with the open circle repeats? I don't need to do it twice because they're going into the same function. These two are going into the same function with open circle, open circle. So we're good. And then 2, let's plug that in there. Closed circle, okay? So I did very sparse number of points because 3x is just a line. If you want to add, this 0 with the closed circle ends up being 3. It's just 3. And then everything else here, if x is less than -3, so with the open circle, and even if it's smaller, okay, it's just going to be 0. Or if x is greater than 2, that's going to be open circle, it's 0. The table's kind of funky for this one. So sometimes it is easier just to jump into the graph. Let's get the y values for the first part. This will be -9, 0, and 6. Yes? Okay. Very good. So like I was saying, a lot of the times, if you're just in pre-calc, just worry about the graphing. And then if you're in calc, then you do other things like you address 1, 2, 3, 4, 5 limits, 6, 7, 8, 9, continuity, etc., right? Involving piecewise functions. So let me know if you want a continuation. We can talk about those things. 2, 3, 4, 5, 6. Okay, I do already have a video on continuity from the left and right and piecewise defined functions, so I'll link it in the description in here. But if you want to go a little more in depth, let me know. Okay, so these are bounded. These are bounded. No arrows on this. Got it? Very good. -3, -9, closed circle. 0, 0, open circle. Connect it. and then 2, 6, closed circle. So basically it's just the line y equals 3x with 0, 0 plucked out. Then randomly 0, 3 floating over here like a little loner. At -3 we have 0, at 2 we have 0, and I'm going to shade this way to the left, including the arrow. Why? Because it's for all x's less than -3. Less than -3 is that way. Or x greater than 2. So shade, 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 and the arrow, because you go forever this way. Again, don't go buck wild and start drawing this line past here, because then now you don't have a function. It's failing the vertical line test. So always keep that in mind. These have to be functions. Okay? I hope this video was helpful. That was my last example. Give it a thumbs up if you liked it. Leave me a comment down below. Tell me what your favorite part was. Subscribe if you haven't already. If you need more review with graphs, I have a full playlist of graphing review from like super basic all the way to Calc 3 3D graphs. And then let me know if you guys want more calculus topics that involve piecewise functions. We can look at limits and continuity and whatever else you might need, okay? Or if you just need more examples, we can do a part 2. You guys tell me. You can also catch me on Instagram and TikTok, Math TV with Professor V. Don't forget to subscribe. I don't know if I said that already. Share this video with your classmates, friends, neighbor, barista, massage therapist, accountant, you name it. All right. Bye, guys. Be back soon.